Amit? Hello.
Hello.
Hi, Amit. It's Mahesh here. So I just wanted to let you know that I'm new to this batch. So I was a part of DSP 31, so which was a classroom mode previously at Bangalore location, because I had to disconnect it because of the COVID situation. So now I'm continuing with it. And my last class was I think logistic regression with that. I had a lot of gap in the middle. So I just want to know like where we are and what exactly like I have to go through.
So we are right now doing the decision trees project.
Okay.
So first is linear regression, then you have logistic, then the next thing is decision trees, and then in the fourth part we have the LDA. So did you close with the logistic regression or you left in the middle of that?
I left in the middle of that actually.
Okay.
So,
So then
but
you
I think,
might have a little bit of,
is there
I mean,
any
you might.
recordings like, yeah, sorry.
So video recordings will be available. So definitely, so you can, I mean, so those things will be shared with you. So all the sessions are recorded. So you can go through the
Okay.
videos, and in
Mhm.
case you will have any troubles and all, so definitely we can discuss them.
Sure, Amit. Thanks very much.
Okay. Okay, so good morning all. So hey, hi Armeet, hi Sakshi, good morning Raghu, good morning Jyoti. So let's just get started. I think the people are still joining in. I see around 50, 60 people who have joined in. Okay. So let's just start in, just give me 2 minutes. I'll just start the things from here, right? So I hope all of you have the data being created up till this point, right? Where we were doing the analysis, where what we did was we kind of got rid of the columns that are not required, and we did the data cleansing part. Please, all of you, make sure that you all have this much part done on your data set. If you have any questions, please let me know. Okay, so do you all have this data set with you, right? So let us get started. So I think let's just wait for 2 more minutes. The people are still coming in. Okay. So in the meantime, what I would like to do for all of you to do as a next step is you all have to calculate the correlation. Okay. Now calculate the correlation of the numerical variables that we have. So let us see who is able to do it. And because this is something that we did in the previous projects also, right? So this is the same thing that we are repeating over here. So please try to do that stuff, like how will you calculate the correlation, which variables you will use, and how you will study that up. Please do that up. Right. So I would like to have the codes being shared by all of you, right? So in order to calculate the correlation, so you have to calculate the correlation. You can create a correlation chart, whatever you would like to do, please try to do that. Which variables we will be using in order to calculate the correlations. So please share that information. Yeah, Parmeet. So right, Harmeet, so we will be using tenure, monthly charges, and total amount. Correct. So these are the three numeric variables, right? Because correlation is something that we can calculate only on the numerical fields. We cannot do that on the categorical data. So you all will have to first create a variable in which you will only keep those three variables, or I will say you will create a data frame in which you will keep only those three variables, and then you will be calculating the correlation on the same. Right. So first of all, what we are doing is we are only capturing all the numeric variables, and then we need to calculate the correlation on that. Please do that. Plus, no one has shared the answer. I hope you all are trying it. Right now, I want all of you to be, writing the codes by yourself, because we are doing a lot of repetitive things also, right? Like EDA is something that remains consistent across any of a modeling technique that you're working on. What we are doing over here is, first of all, we are creating the variable in which we are trying to keep only the numeric variables, right? So this sapply function is something, why do we use it? This is something used to check which all variables are numeric, right? So we are saying in this data frame, I would like to check each variable, which variable is numeric and which one is not. So if I just run this much part of the code, okay. So this gives me the which variables are numeric and which are not. So I can see online backup, online TV, billing method. These are all the character data, whereas total amount and the monthly service charges, and you will be having one field of tenure, right, which will come as numeric. Okay, these The ones that are true, I would like to only keep them. So if I click on numeric dot where now, so these are all the variables that we are having, but we would only like to use the variables which are the numeric over here. So we will use, when you will calculate the correlation, it will only use the ones that are the numeric fields. So let us calculate the correlation on the same. And we can see the correlation matrix now, right? So this is how the correlation looks like. So you can see from here, right? Tenure, right? Tenure is highly correlated to the total amount. That if the tenure will increase, so definitely the amount will increase. And this is very much logical also, right? If you are using it for a longer time, if you would have, taken the subscription for 11 months, right? So you will be paying more amount. If you would have taken it for 2 months, you will be paying a lower amount, right? We can see monthly service charge. It is also related to the total amount. If your monthly service charges are more, definitely your total amount will increase. Am I right? Plus, so if I see over here, I can see that tenure is something correlated to the total amount, and monthly service charge is also something that is correlated to the total amount. So what will happen in this case is, now this can lead to some multi-collinearity as well, right? Because I know that if the tenure is increasing, amount is increasing. So my data will get kind of extrapolated if I use all the variables again, because these are all related to each other. So I am saying if tenure increase, amount increase. If I say monthly service charge increase, the basically this amount increase. So that way somewhere what will happen is there will be some extrapolation that will happen in the data because of the multi-collinearity that we have between the variables over here. So after we have seen this, what we can do now is we can actually create a correlation chart also to in order to understand how this correlation is happening. So let us create a core plot. Okay, core plot is the chart that we have. So let us create that. Oops. What is happening with my R? Again. So we are using the dataset that is this is a project that is available on your LMS, the decision trees project. So if you will download that project over there, you will find this dataset in that project over there. So Mahesh, this is that particular dataset. This R is creating the problem for me. Let me do one thing. Let me just open this everything just one more time. This is creating a problem. Yes. So you use the pairwise observation if you have the missing values. So in that way, it will only pick up those values where there are no missing values in that pair. Correct. I'm just setting up my working directory. I just have to rerun some of the stuff. Okay. So this is the correlation chart that has been created. Okay, so you can see 1, 1, 1 and tenure to total amount. This is coming as 0.8. Then monthly chart that is coming as 0.6. So we can see that correlation over here in this chart like this. Okay, so we can see which the monthly services tenure and total charges, they are correlated. All these variables are correlated to each other, and that makes sense also. Now what we will do is we will do some analysis and we will try to explore the data over here, right? I would like to see, uh, do we have more gender? Do we have more males or females? Do we have, what kind of data do we have across the different variables that we have, right? So we will try to create some plots over here. So how are we creating the plots? We are using the ggplot functionality, right? We are using the ggplot package over here in order to create that. So how will I do it? So I am saying ggplot on this data frame. I would like to plot x equal to gender. Okay, this is something I would like to have on the gender over here. Then I am defining what should be the title of my chart, what should be my X label. So, and then I'm defining what is the chart, the type chart that I am creating. And we have defined the aesthetics over here, what I want to show on that chart on this. Right. So all of you, please do this. So you all have to create a chart where we have to showcase that do we have more males or females, right? So this is what we are doing over here. So let's create that chart. And let us see the chart is created, plot 1. Let us visualize it. Okay, so this is how the chart looks like. So we have almost similar kind of a data, right? We have male and female as somewhat equivalent. Okay, you can see around 50%, 51% are around female created. Sure, Raghu, let me just explain you. See, what we have done over here is we are saying that we want to create a ggplot. This is the data frame that we are using. Okay, so if just I will just like to reiterate the thing. So if I say ggplot, I give the name of my data frame, that is df underscore churn. Okay, then you define the aesthetics. In the aesthetics, what we are want to do is on the x-axis I want to showcase the gender. Okay. Then if I create plus geom underscore bar, okay, if I create normal bar chart, this will create a bar chart for me where I can see this is the count of female and this is the count of male. Okay, this is based on the count. Automatically, when you create a geom bar, what happens is it creates a chart on the basis of the count, that how many males and how many females do I have, correct? Then what we have done in this chart is we have applied some titles and all, that is plus GG title, right? So with the help of GG title, you can define a title. So suppose this is, the title is gender, so you will get a title over here. So you get title on this chart. Now on this bar chart, what we have done is there is one option that we have used, that is coordinate flip. What is the use of this coordinate flip? Can anyone tell me? What is the use of coordinate flip? Right, so it will flip the axis. X will become Y, Y will become X. Okay, so that is what that coordinate flip will do. So that is something that we are doing over here, plus coordinate flip. This will rotate the chart. It will become like this, horizontal. Right now what is happening is we are showing the chart on the basis of count over here. But what we have done is we have changed this chart in the form of a percentage. So in order to change that into the percentage, what we are doing is we are saying in the geom bar, okay, in this, what we are defining is we are saying on the y-axis, right? So whatever you have on the y-axis, I would like to show that in the form of a percentage. So you are saying count of whatever y-axis divide by the total count. Okay, so count of male divided by the total count of male plus female. That way the chart will change into the form of a percentage, and then we are multiplying it with 100 in order to get that output in the form of a percentage over here. Okay, so this is what we have done in this step, and we have defined the width of the bar, that what, how thick the bars should be that we are creating. So that way, if I now create this plot, okay, when we now create this plot, and because we are saving this chart in the form of a variable, and the name of the variable is plot1, what you will see now over here is if you run this plot1, now the output is coming in the form of a percentage over here. So around 50%, 51% are females and 49% are males. So we are just to change that calculation in the form of percentage calculation. That y-axis, I want to show the males and female in the form of percentage rather than count over here. Okay. So I'll share this code with you on the chat also. Okay, in a similar way, what you can do is you can create a plot2. Previous chart we have created on the basis of gender. Now we would like to create on the basis of partner. So how many users do we have who have a partner and who do not have, right? So we would like to analyze that as well. So we are creating plot2. So everything will remain the same, just that on the x-axis instead of gender, you will put partner over there. Okay, so let us create the plot2 and let us see how the chart looks like. So if you will create this plot2 over here, you will get yes and no. So again, almost the data is like 50-50%. that 50% of the data we have where the people have a partner, and 50% of the people where the customers do not have a partner. Oh yes, so you do it over here, right? Like this chart that we created. So like in this, if you put y equal to this, so I will not require this over here now. Up till here only I will run this code. Okay. So if you come on this now, you can see the plot 2. Oops. Oh, no, by default, because it requires an x and y static. So this is x and this. Okay. Right. So this is what you were asking. So instead of doing a coordinate flip, what we have done now is I just said on the y-axis, I would like to show the partner on the y-axis instead of x-axis. So that also you can do it. So in that case, you will not require the coordinate flip. Now, similarly, create a third chart on the dependents, and please let me know what analysis you are getting with the dependents chart. What type of analysis this chart is showing you. Okay, so if I create plot 3 with dependents over here, so let us check out what this analysis comes up. So we have more data where we do not have dependents and less data where people have dependents in them, right? So we can see almost like 64% of the customers, they have the dependents, and around 35% of the people, around 35% of the customers, they do not have the dependents, right? This is what this next chart is showing you. And if you would like to see all the three charts together, right? If you want to see all the three charts to be coming together in one single view, so you can use it a function that is grid.arrange, right? This is a function that you can use, grid.arrange, which is coming as a part of grid extra. If you will not have this library with you, grid extra, you will not be able to use this function, right? So please make sure you have the grid extra library in package installed in your system, right? So then if you will use this, you will find that you will be able to see all the three charts together in one view. Okay, so you can see it. So let me zoom it up. So now I can see all the three charts together in one single view over here. What was the another way that we learned of showing the charts in one single view? Does anyone remember that? So we did the same thing. Right, yes, that is the partitioning MF row, multi-frame row, partition multi-frame row, in which with the help of that also you can do the same thing. Right, so if you see, we are just exploring some more features in the R that how we can achieve that same thing. So I have defined that I would like to have first the plot 1, then the plot 2, then the plot 3, and we have defined number of column equal to 2. Okay, so what is the number of column? So when you zoom this chart up, so these are called as column 1, column 2. So you have two columns. if you would have said number of column equal to 3, all the 3 charts would have come in one line, 1, 2, and 3, right? So that is how you would have been able to change the view over here. So let me call it as number of column equal to 3. So you can see now all the 3 charts are coming together in one row itself, 1, 2, and 3. But the charts are looking little compact, right? I mean, they are looking little tacky. So it's better we can we keep that stuff as 2 column itself. Okay, so what is the analysis we got? We can see gender is more or less equal, and most customer do not have dependents, right? This is something that we see. And partners, the in the partners are also something which are more or less similar, right? So data shows that the most of the people, I mean the people, customers having partner is also similar. Now we would like to create another chart on the basis of call service. So how many people are availing a call service and how many are not, right? So what is a call service? So which is this feature, how many of the customers are using the call services and how many are not. So you can create a chart on that basis as well. Okay, you can create. So let me just share this. I mean, for that simplicity. I hope I'm not going fast. Please let me know, if in case you want me to slow down. Okay. This is something, like even if you will be going somewhere for interviews and all, and like in most of the cases, what happen is the companies, they actually, these days what they do is they share the case studies with you, right? So in the case studies, so like, this is how the interview process happens in the companies, right? When you go for any of the analytics roles. So let me just discuss about that on a little bit over here because this will just help you around. See, what happened is there are two ways these days the companies interview the people, right? What they will do is either they will call you in, and then what they will do is they will take your aptitude test, they will give you some case study to work around, and then they will take your interviews depending upon how you are qualifying the rounds. And many a company of the companies, what they have also started doing is that they will actually mail you a case study. Okay, they will send you a case study over the email, and they will give you a week's time. They will say, okay, you can take a week's time and you have to submit this case study to us. And how well you work on that case study, that is how you will be called for the interview round. So in that case study, you have to be very, very elaborative. You have to make sure that you showcase each and every, the each and every analysis over there. And in fact, like many of the I mean the students also who I mean whom I train, so they keep on sharing those case studies with me, right? What they do is they mail me that case study and they ask me that, Amit, can you please help us with this case study? And then I sit down with them and I try to help them down on that case study. And when they submit it, so that is how they go for the next one. Many of the people, they do that case study by themselves also, or they connect with their the friends and all to discuss what more that can be done on that. So please be prepared for that kind of interviews as well, right? So the case studies will be sent to you, like like I myself have, for many of the companies I have delivered, I mean the case study, because when I also used to go for the interview, they used to send me the case studies to me. And 2 3 days back also, there was one of the students there was one of my students who got the same stuff. So let me show you this thing over here, right? So over here also, if you will see that, in fact, this student actually got the same case study that we are doing in the we have done in the classroom sessions also. I mean, the data was a little bit different, but the case study was on the similar lines. See, he got this similar case study that he shared that with me, that he has to submit this case study to the one of the companies. The company name is Teleperformance. So he was called in for a data scientist role. So they sent him a case study which was again on that the loan, whether a person will default the loan or not. This is a similar case study, right? So if you see, they have given them each and everything that what they actually have to do over there. So this is a classification problem where you are supposed to find the loan payment status, that whether a person will pay the loan or not after 1 year of issue. Loan term is this, programming language. See, they have not even kept a constraint that you have to deliver that in the Python or in R specifically. They have given you your own preference of in which language will you like to submit it, right? Okay, so over here they have given them what is expected. So when submitting the results, make sure it contains the confusion metrics, accuracy, variable importance, methodology for modeling, prediction probability, various insights, and champion challenger in Python or R. You see, in that case study, they are expecting each and everything, right? The way we are doing in the classroom sessions, right? They want all the insights that you can figure out from the data. After the model has been created, you have to create a confusion matrix. You have to calculate the accuracy. Model gain is like the same predictions can be done by various modeling techniques, right? You can create a model with the help of logistic regression. Also, you can create a similar model with the help of decision trees also. So you have to specify that, when you created this model with logistic regression, this was the accuracy, but when you did the same thing with decision trees, your accuracy increased, right? You have to specify which are the important variables that you have, right? How can you find the important variables? With the help of significance, right? The p-values that we find, right? So this is how the things happen, right? So I mean, so I'm just wanted to give you a little bit that the things that are happening, so that gives you a little bit idea on that part. Okay, so this is where that all these things that we are doing over here will make that impact, that how regressive or how the how much detailed analysis that you can put on the table in front of your interviewer. Sure, yes, I will share the previous codes. I think already the codes are already over there on that chat. I mean, you are asking of this case study. Oh, I hope you are not. I thought the previous case studies that we have done, right? So I'll just share this plot 1, plot 2, plot 3, all these over here. Okay. So this is also I'm sharing grid over here. Okay, so I've shared the codes up till the point where we have done the stuff. Please let me know if anything I've missed over here. Are you all able to create this plot these plots 4, 5, 6, 7, all the 4 plots in one single window? And please let me know what are the analysis or the insights that you are getting. Hello, class. Seems like you all are very, your energies are drained. Did you all have a lot of partying on the Christmas Eve? Yep. Have you all get these charts? Okay, Baldev, yes. Raghu, okay. So what is the insights that you're getting from this online security chart? What insights are you getting from here? Oops, okay, so Mahesh, if you're feeling my speed is a little fast, I'll just slow it down.
No, I
So
think
Bhuvnesh,
that's fine. So it's just like I need to practice it a little bit.
okay. Yeah. So package is this grid extra. So I'm going to show you the package that we're using over here is that is grid extra for this. So you need to install the package grid extra. Okay. So this is the package that we need. Here's a plot 7 if I see over here. I see the chart. So online security, we can see most of the people have not enrolled for it, right? This is something happens with us also, right? Like Airtel people, they call us that, sir, please take this service, please take this service. And we always deny them. It is very few people who take such services, right? Yes, what exactly do you want? I mean, you're asking to replace the strings. I mean, you want to replace a part of the string. So for that, if you want to replace it, you will be having a function that is substitute, I guess, or is it replace, right? So if you use that, so you have this substitute function that you can use, right? This will be able to help you out over there. And there is sub str also, substring that you can use, right? So in this case, you can replace, you can define the position that from which position do you want to start extracting, right? Like for example, I say sub str, I have a text like welcome. In this, what I want to do is I want to extract something from here, starting from the position 3. I want to extract 2 characters, 3 characters. So I'm just given the same position, two characters from there. Oops. Start and stop from 3 to 5. Okay, so LCO. So this is one thing that you can use, or you can use the substring function. You also have a replace function as well, right? So you can replace the values in X, whatever you specify. So there are a lot of functions for doing that. Okay, so after the observation, you would have seen, let me just create all these charts together also so that we can see all the charts together in one single view. So we can see when it comes to call service. So yes, mostly the people have the call service, right? Whenever if ever they will take any connection, so most of the people will take that calling service, right? That is one of the main reasons we take that the services of any of the network providers. Multiple connections. So we can see most of the people do not have, and many of the people have that multiple connection also. And when it comes to internet, we can see most of the people are using fiber optic, then DSL, and there are a lot of people who do not have an internet connection at the same time. Online security. So mostly the people do not have an online security, and very few people have the online security that they have taken up. Okay. So we can create some charts on the basis of online movies, agreement, billing method, and likewise billing method and payment type. So everything is the same, just we are just picking one variable at a time, right? We are just trying to analyze the variables one by one and try to figure out what type of data do we have. So all of you, please try this out. Are you able to create this? If you can just share what are the different insights that you're getting from here. So what is the insights that you're getting on the billing methods? So what kind of billing method people are using mostly? What kind of payment methods the people are using most of the time? Whether people are watching the online movies or not, right? So you can see all these type of analysis. And in this, due to this pandemic, all the companies that had their predictive models that were created, they actually had to change all their models due to this pandemic that has happened, because everything has turned, right? All the variables which were significant previously, they became insignificant in this period. So, this is something that, since I was working on the models, so we saw this trend. So I was just sharing this because, this is also a kind of a question that can be asked from you guys in terms of pandemic. So what impact the pandemic would have had on the different predictive models that the company would have been using? Whether would they have changed it, or they would have been able to continue with the same stuff, right? So this is also one of the very, the common question that is being asked these days also into the interviews. So let us create it. So we can see from here that if I just expand this, zoom this chart, So on this chart, I can see that almost like around 35% of the people are watching the online movies and mostly no. Billing method. So people are taking the billing method over the uh, email, and most of the people and many of the people without that email also, right? Payment method, I can see electronic check is the favorite way of payment method, right? Credit card and bank transfer, they are of a lower priority. And when it comes to agreement, so most of the people have signed in for month to month agreement rather than doing for a 1 year agreement or a 2 year agreement. How can I change the color of the bars? Right now they're coming in the grayish color. How can I change the color of the bars? Nice. So can I use the color? In the geom bar, we can use of something like color. Sorry, in this we use fill, right? Fill equals to red. So that way the bar of the colors will change. I hope you all remember these functions that we did in the ggplot. Fill, color, and you have shapes. If I'll re-execute this now, so one of the charts will come in the red color now. Right? So this chart has been changed into red color now. Okay. Now what we will do is the complete EDA process has been done. Right? We have analyzed all the variables. We have checked the correlation. We have checked up for the missing values. We have, also seen the correlation and everything, right? So all the things are now done. So now what we will be doing is we will come to the portion of where we will be removing the variables which are not required, so that we can then proceed to the portion of where we will start creating our model. Okay, so we can see that we saw that three of the variables are highly correlated, right? Monthly service charges, tenure, and total charges. Now these three variables are correlated to one another, right? If service charge will increase, total charge will increase. If your tenure will increase, your total charge will increase. So this will lead to multicollinearity, correct? This will lead to some multicollinearity in your data. So as a result of which, what I will do now is I will only keep one of the variable, that is total charges. It doesn't make sense to keep all the variables because they are correlated to one another. So whatever the impact the total charges will have, that is something correlated to tenure and service charge only. So what we will do is we will remove the other two variables and we will keep only one of the variable, that is total charges. So what we are doing now is we are saying tenure we will remove, payment method we will remove, right? Why we are removing gender and payment method? Can anyone tell me? What's the reason that we are removing these two variables? Right, because if you will see, gender is almost like equal, right? So we have equal number of male and equal number of female, right? So there is not much variation in that data, and that the same is the thing with the payment method also. So the data is almost similar. If you want, you can keep that also, right? But if you think you do not want to keep it, you can remove them. But for the correlation perspective, over there we will remove that tenure, right? If you want to remove monthly service charges also, you can remove that also. So these are a couple of variables that we will be removing from here. Okay, so that my model can work faster and give me the results at a faster rate. So now from here we start the section of model development. Okay, so we have this data set with us now, which has 17 columns, and we have 12,335 rows of data in it. So whenever we start with the model development, what is the first step? I mean, if you are writing the code now, let me just know. I'll just wait for you over here.
Hey Amit, I have a stupid question actually. So when we know that from Gini index and p-value, what are the variables which are actually dependent and which would make sense for to be added to the model? Why do we do the EDA again?
See, EDA, so the Gini index is something that you are using in order to find which variable is significant for the model. Okay. But the EDA portion that we are doing over here, this is something that we are doing to understand what data do we have, what kind of behavior that data is telling us, right? Because from this analysis that you have created, from here you can actually get a lot of insights on which a lot of decision making steps can be taken up by the company, right? So they, if they see that most of the people are not watching online movies, right? If I get this insight, like from this chart I was able to see that mostly the people have not enrolled for the online movies. So if you will see, the whole idea of this data analytics is that the company should be able to do better decision making, right? So now from here they will get an idea that okay, people, there are only 30% of the people who are watching online movies on a network, and almost 65% people are not using those services. So they can think of bringing some offers and some changes into their way of working so that more people get start enroll into the online movies, right? So that is where this analysis will be beneficial for the company. So they are able to realign and restructure their existing processes, plus they are also able to predict how the customers will behave, whether they will leave the services or they will not leave the services. Okay, so it's like a complete descriptive and predictive analysis that we are doing in this complete process. Right. So, you can actually see that, okay, then you can further deep dive also. Like, for example, okay, if the people who are taking your services, to which kind of genre do they belong? So if I see mostly the young customers are watching the online movies, so they know now they need to target the senior customers so that they also start watching the movies, because by that what will happen is definitely the percentage share will increase, right? And they will also then have to further drill down that why the senior citizens are not watching the online movie. Maybe they are not having the good titles with them, or some other reason. So that is where that the complete business intelligence will come into play. Right, I was like, I was watching one of the videos. This was very interesting. I mean, I'm not sure if my you might all also have watched that video. So it was on this airline industry. So they were giving some very useful insights that there was one airline company. What they started doing was that the food that they used to serve, right, the food that they used to serve on the flights, they reduced that food serving. In each food serving, what they did was they reduced one of the olives. Okay, they started serving one olive less. Now, because the olives were served less, due to which the weight on the airplane was decreased. Okay, and when that weight on that airplane was decreased, it helped them in better fuel efficiency, and with that they were actually able to save a lot of money on a yearly basis, right? And there was also one of the very interesting facts, so that I found really funny, that in the Japan, there was an airline industry. What they used to do was they before the people used to board the flight, So they always used to ask the people to, first, uh, go to the restrooms and relieve yourself, because that also helped them reduce the weight, and they were again able to save a lot of money on the fuel charges. Right. So these are the kind of stuffs that happened in every industry, that how they can optimize and cut down their costs and increase their revenues. And the same thing, similar kind of stuff also happens in the retail industry a lot, right? The promotions, offers, and all. So there is a technique that is called as market basket analysis. So, right. So cost cutting. So it is not like cost cutting, right? That is like a smart move, right? So cost cutting is when you are like, reduce down your services that you are offering them. So in second case that I was telling you, so they were not reducing down your services. They were optimizing that cost. Correct, right, Raghav? So that was more like cost optimization. Like, this example of the cost optimization would be the Apple, right? What they have done is they have now stopped offering the chargers with their mobile phones. Now that is the perfect example of a cost optimization. Although they are promoting it as something like the weather. It is very helpful for the weather and all. The climate control. It will be very useful, but at the end of the day, they have just done the cost cutting, right? That they are selling the chargers separately, phones separately, so the person will be ordering both the two things, and they will be able to ship more products also. So that helps them save their cost of logistics also. Plus, people will buy now two items instead of one, so that helps them, generate more revenue. Okay, so all of you, please split the data into test and train now. So we have 12,000 rows of data, so we can keep 80,000 of the data in the training data set and remaining 20% in the test, or you can keep 70% or 30%, whatever you feel as the best. So how can I split the data? So there are two ways we know, right? One is by the help of Caret. We can use Caret as the library, or CA tools, right? So we have two options of splitting the data into two parts. Please, all of you, do that step of breaking the data into test and train. Are you able to do it? Anyone who has broken on the data set? So over here, I am showing you that example with the help of Caret, right? And you can do it with the CA tools also. So what we have done is we have created a variable in train, where we are saying that we would like to create a data partition, and partition has to happen into 70 and the 30%, right? So I'm saying create data partition. My data frame, this is my data frame. On the basis of churn variable, I would like to break the data set into 70 and 30%. Okay. And then what we will do is we will set dot seed, and in the training data set, we will keep the data that is true, and in the testing, we will keep the data set that is false, right? So we have used minus in train, the data that is not there in this training data set. Okay. So this is how you will be able to create your test and training data sets. So we can now see in the training data set, we have 8,635 rows, and in the testing data set, we have 3,700 observations with us. Yes. So set.seed can have any number, right? So we keep this number as same, right? Like if I keep this number as 2000, so now next time also, if I will run this same model, so in the test and training data set, I will get the same rows. But if the next time, if I change the number, so what will happen is I will get different set of rows. Right, all of you, Naveen, Pooja, Raghav, Sahil, are you all able to understand what we are doing over here? Akshay, Baldev, anyone having any doubts or queries up till here? Okay. Right, so now we can confirm the splitting is correct, right? So we will just count the number of rows that we have, so we can see the dimensions. So we can see in the training data set, we have these many rows and these many columns. And in the test data set, we have these many rows and these many columns. So definitely we have got a correct splitting of the data set that has happened into test and train. Now what we will be doing is we will be creating the decision trees. Okay, now this is where the part of modeling now comes into the picture. So modeling, we all know modeling is just a one-step stuff, right? You just have to define your function, you have to define your data set, and your job is done, right? And then we have to check out which variables are coming significant and which variables are coming insignificant. That is how we create the models. We saw that thing in the linear regression also. We saw that thing in the decision tree, logistic regression also. So like, we did 2 or 3 models in the linear, 2 models in the logistic regression. And now we are on to the part of the decision trees over here. So how do we create a decision tree? So for that, what we do is we use the library that is rpart, right? So rpart over here stands for recursive partitioning. Okay, this is what we understand from recursive partitioning. So what is recursive? Recursive means at each step, the tree will be created, which will have branches inside that, right? So that is called as recursive partitioning. Now in the recursive partitioning, so this for using the rpart function, you need to have a library that is the rpart itself, right? The name of that library is rpart. So before using this, please make sure that you all have installed the package rpart. Okay, please install this package over here. And after installing, put this package into the library also, rpart. Okay, and then you will be able to create the model. So I will explain you what is written over here. Okay, so now what we are doing over, so please, first of all, let me know that all of you have created your test and training data set. So, and you have installed this package also of our part. Okay, so can anyone tell me what was pruning that we discussed? We discussed something called as pruning when when we were going through the theory of the decision trees. So what was that pruning?
Then we have to limit the number of nodes and branches of trees.
Right. So there were two types of pruning. One was pre and one was post. So what was the difference between? So I mean, your answer was correct. Like what is pruning? So cutting down the extra branches, correct, or reducing down the nodes. There were two ways of doing that, right? One was the pre-pruning. In the pre-pruning, what we do is we define the number of branches that we need before even we create that model, right? That is pre-pruning. And post-pruning is in which first we create the model, the entire model is created, and then after that we do the optimization of that model. We see which all models are not coming as correct, okay, and which all branches can be reduced down from there, correct? So this is what we discussed, and there were a couple of ways that we discussed in the pruning, that you can also define that a branch should only be created if you define how many records would you like to have in each branch. If you say you need to have at least 20 records for that the branch to be created, so it will only be created in that case if you will have at least 10 yes or no, or 20 yes or no over there. So there are multiple ways of doing that pre-pruning. Now over here, what we have done is we are using a rpart function, recursive partitioning. We are defining the formula. My formula is my churn is the variable which is the predictor which I have to predict. By default, I am saying this churn variable depends on all the variables that we have in the data set. Okay. Then we are defining training, that this is the data set that on which the model has to be created. Then we are defining method equals to class. Right. So remember, we use this method function in the logistic regression also. Over there, we said method equals to binomial, right? Because in the logistic regression, what happens is you can only have two type of outputs, 1 or 0, true or false, or yes or no. But in case of decision trees, you can use this decision tree for more than two classification also. So that is why we write as method equals to class, right? Yep. So that is the same thing, right? So method or the family, so that is the same thing. So it represents the same information over here. So when you say family equals to binomial, or you say method equals to method equals to family, that is the same thing. Because we are using a different function, they have just changed the name of that part. But at the end of the day, this is the same stuff that we are doing. Okay. Then what we are doing over here is we are pre-pruning that model that we are creating. We are saying we should have a maximum depth of 6. So it should have 6 levels, the tree that we create. Okay. Now we will create this tree over here. Now when you use this rpart function, so how this, the technique that is used in the background for calculating the significant variable is that technique is use of Gini index. Okay, it uses the Gini index technique in order to identify which variable will come at the top and likewise. So let us create this model tree now. Let us just create this. All of you, please write this command. I will also share this over the chat. Okay, so please all of you create this.
Amit, can you please tell me about the control function? It's a max steps.
So control functions, which is you are like, because this R part is a function that we use to create a decision tree, right? So in this, we are defining that how many levels you would like to keep inside this, right? So like the tree will have 6 levels. So it will use, so first variable, then second variable, third and fourth. It will keep the layers up till 6 only. And if you define 5, it will keep the layers up till 5 over here. So that is what that control is doing. So we are controlling the number of layers that we would like to have in that chart. Right? Or I couldn't say, the nodes that you would like to have. So that is where we use this control. Okay. So now the model is created. So first of all, what we will do is we will try to see how this tree looks like, right? Up till now, we were discussing and seeing all the things and doing the calculations manually. But now over here, we will see that our plot being created for us. So this is the function that you use for creating that decision tree. So I'll zoom it up. Oops, this is looking too big. Okay, so this is looking too small. Now this is a little bit of a problem that we have in this decision trees. The text becomes, you have to do a lot of stuff in order to get that text right over here. Okay, so now it is still coming properly, right? So you can see now over here. So what it is doing over here is, this is how the nodes have been created over here. So if you see now, so first of all, please, all of you spend that time by yourself. Just spend 1 minute and see what all variables are coming over here and what this chart is showing you. First of all, try to create and make sure that it is looking and coming up properly. Okay, are you all able to create it? Okay, so CEX that you see, this is basically just like, this is something that you want like to scale up, that how the numbers and text that should be visible on this chart. So when you are changing that CEX, when you are increasing, so it is like increasing it by 50%. When you make it 0.6, it increases by 60%. So you are changing the size of the text, right? That is what CEX stands over here. This is just a formatting stuff. So magnifying. So if you will make it 0.6, so you will see that this text that you have on this chart, it will come with a bigger font, right? So you're just magnifying that thing over here. Okay. So now in fact it is looking much more clear than before. Okay. So now, first of all, let us start from this step over here. Now let me try to explain you how to read this chart over here. So now what this chart is doing over here is this chart is actually plotting the variables, and it is telling you what percentage of the data is, in the what percentage of data is yes and what percentage is no. Remember, this is the same thing that we did in that problem of the HR, the job attrition, right? We used to calculate the percentage, which variable has what percentage chances are the person will leave and what are the percentage chances he will not leave, right? Now over here, that variable is churn. What percentage of the chances are that the person will stay with will use your services, and which customer will not lose your services, right? That is what the data that we have over here. So first of all, let me come back in order to explain you this thing. I'll use the Excel over here. We have the churn data. Okay, just give me a second. Let me open that file. Okay, so in the training data set, right? So basically, if you will see, maybe let me use the R. Okay, that will be better. So we are, because we are showing this all these things on the training data set that we have created, so it will be a little problematic. Okay, so let's see over here. So we have a training data set. Training. What I will do is, let me use the command table training $churn, and let us create it. So we can see there are 4,710 values in that training data set where the churn was no, and 3925 values where the churn was yes. So what is the percentage of no? The percentage of no will be 4710 divided by the sum of 4710 plus 3925. Okay, so you get 55%. So the percentage of no is almost like 55%, and yes will become 45%. So this is what it is telling you at the top over here, that 55% is no and 45% is yes. Okay, this is the first node where you have complete data. Are you able to see it? Okay, now it is saying the 100% data. So now after that, the first node is created on the basis of agreement. Okay, on the basis of agreement. So the variable is how many people had 1 year and 2 year agreement, and third one was the month to month, right? Because if you will see in the data, we had 3 type of agreements that we had: 1 year, 2 year, and month to month. So what it has done now is, on one side, it has brought those peoples who have taken 1 year and 2 year agreement. And on this side, you have that data where you are seeing that how many people have taken the month to month agreement. Okay. Now, based upon that, there is a further bifurcation that has happened. So out of that, how many people are not leaving the services and how many people are leaving the services. No and yes. This is the same percentage that it has showcased over here. Now there was like 100% of the data. So 43% of the data was such where the people had taken 1 year and 2 year agreement, and remaining the 57% of the data was where the people had taken the month to month agreement. Okay, this is how the data has got split it up into two branches. Okay, so in these two branches, for each branch a calculation is being done that whether the person is taking like how much percentage of the people were taking uh, were no in the term of churn and how many people were yes. So what this tree does is this basically highlights when you see it's written yes and no, it will write that thing at the top which is in the higher percentage. So like if you see in the first node the data with no is in the higher percentage, so it writes no at the top. And in any tree, if the percentage of yes is higher, like you can see in this case, 40% is no and 60% is yes. So it has written yes at the top. Okay, this is how this tree gets created. So it highlights that thing at the top and color is also changed according to that. Okay, are you able to read these values? Let me just zoom it up and let me see. Yep, so you can see from here. It's much better. The 1 year and 2 years and month to month. One second. No, I think there is something. Okay, then what is happening over here is, then if you see the data is getting further drilled down on the variables that is like monthly service charge, and then you have another variable that is total amount. Now these variables that are being created, these variables are created in the order of their significance, right? So the highest significance was coming as per the Gini index for the agreement. Then the significance was coming for monthly service charges, and then you have total amount, right? And this is how the branches have been created. And finally, after the end of the branch, we can see that how the number of data points that you are getting, where the people are taking the services and where the people are not taking the services, right? So for that, this is the final terminal nodes where you can calculate the percentages based upon the different variables that have been created. So these lines are also not coming. Way off. Because this summary comes too big that for each variable it shows all the calculations. So if you see over here, now over here we are gives you the complete analysis over here, that what that standard deviation and everything is. Okay, so it gives you the variable importance and everything. that which variable is important and which variable is not. So you get all the values over here being calculated based upon the Gini index technique that you use. And if you see now, you will be able to see those variable importance. What is the importance of each variable that is being calculated, right? So agreement, monthly survey. So you can see this is coming in the decreasing order over here. So online movies, online backup, online TV, these are the least significant variables that we are having. Then you have the node. In the node one, it is telling you that how many observations that you have. So this is the first node, okay? Then this is the second node and the third node. So that is how the nodes are being created. Now over here, you can actually read out and kind of understand this more, this in a more detailed way, which you will see over here now. You see now what is happening over here is at the first node, okay? Now, in the first node, you will see it is giving you that in the node one, you have these many observations. Okay. Then there is a complexity parameter that is calculated. Okay. Now that complexity parameter is based upon that Gini index that you calculate. I'll just show you that formula also, how you calculate this complexity parameter. Predicted class is no, right? What is the predicted class? That higher percentage is aligned towards the no, that the people will not churn, they will not leave your services, right? That is what it is telling you. And expected loss is the other variable, that is yes. So that is 55% are saying they will be no, and the loss that you are having is that is of 45%. That is the yes, right? The thing that the kind of customers that you will be losing over here. Okay, so this is the probability that you see over here. So we have the counts, class count. Class means yes and no. How many no do you have and how many yes do you have? Then you have the probabilities of that, right? This is the same thing that we saw in that example also when we were doing it in the theoretical sessions. Okay, are you all able to grab this, what we are discussing? Now what you have over here is, now on this, it gives the further bifurcation that how the data gets split into the left sun and right sun, right? So left sun and right sun means over here, if you will see, this is the data that is going on the left hand side and this is the data that is going on the right hand side. Okay, so on the left hand side, you can see 3,692 observations are going, and on the right hand side 4,943 observations are going. So if you will calculate the percentage, right? If you will calculate the percentage, you will find that this is the 43% and this is the 57%. So that is the same percentage that you see over here. Okay, this is the first node is getting split into two parts, that is left and right. Okay. Then what it is doing is, it is now after that first node, it is picking up the other primary splits that are happening, right? So you have the next variable that is coming up that is being split over here is, that is agreement. Okay. There is an improvement that happens of 512. So, improvement means you can call it as homogeneity. How much homogeneous data do you have? Okay. There are 0 missing values in that variable. So it is showing you that as a part, because we have already cleaned all that, we already know that we do not have any missing values in the data set that we are using over here. So you get that information over here. Then it is telling you the next variable on which the split is going to happen, that is total amount. Okay. So it gives you all the variables in that order of hierarchy over here, that how these variables are being separated from one another. And then it gives you the detailed analysis for the node number 2, that is this. In this node, how many observations we had? We had 3,692 observations. It calculates the complexity parameter. Okay. Then it is saying predicted class no. The same thing comes up over here. For this node, it is saying that the people who have taken the agreement of 1 year or 2 year, so majority of the people are coming, the data is coming inclined towards the no, and expected loss is 25%, that is the percentage of yes over here. Okay, and then it gives you the probability of the node also, that how much data has come on this node and how much data would have gone to the third node. Okay, so these are the few initial things that you first of all you have to understand. Okay, same way you will come over here, the same analysis will start for the node number 3. So node number 3 is this. So how many observations have gone over here, and you have predicted class yes in this case, right? So you can see yes has a higher percentage, so loss is 0.3935, which is 40%, which you can see over here. 40% is the loss that is happening over here. So it shows the output in the form of percentage plus the loss as in the value which is coming in the lower percentage, that is called as the expected loss over here. Okay, same way you will have this information for all the nodes. Then you have the node number 4, right? So then you will have the data for the node number 4 over here. Then you have the data that the node number 4 is over here, right? So no, which is 21% of the data. Then you have node 5, which is over here, because in this diagram these things are getting little bit hazy, so due to which the things are not visible. But there is one more chart that you can create in order to improve this, and that chart is rpart.plot. You can also create this chart. This will also give you the same analysis. Okay, just the visualization will be different. So if you use rpart.plot and create this model tree, so you will see this is how the chart will look like over here now. The analysis is not changed, just a little bit of a different view you have got. So for creating decision trees, you have multiple options that you will see over here. Okay. Are you able to create this? So yes, actually, I will be coming on to that. What is complexity parameter? So just to give you an idea, like what exactly that complexity parameter is. So it is something, this is used as a technique in the decision trees to optimize the tree size. Okay. So what happens is if you add a next node into the decision trees, if the complexity of the data will increase, right? If you add another variable, and say suppose in that case what is happening is that the complexity is increasing, so decision tree will not continue, right? Decision tree will stop over there. So that is how this complexity is useful in understanding whether a new node will be created or not. Okay, so there is a formula for that, right? So I'll just show you that formula also, that what exactly that formula we use for the calculation of the complexity parameter. Okay. Yes, actually we did that pruning. We did the pre-pruning over here in this model. If you will see over here, we defined maximum depth equal to 6. So that was the pruning that we did. Max depth equal to 6. This is the pruning where we are defining it will not go beyond this depth, right? See, when you do the pruning, it doesn't mean that it will have those many levels. It has to have that. But if in case the tree will be going beyond that level of 6, it will stop there. Okay, that is what the max depth over here defines. So we are defining it will not go beyond this size over here. Yes, Sakshi. So that is why you are not having that. Correct. Okay. See, it will look a little bit, complex when you look at for the first time. But do not worry, I will be explaining you each step over here so that it gets crystal clear to all of you. Okay. So if you see over here, what we are now doing over here is, first of all, we are creating the trees at each level. We are defining the nodes, and we are just, if you will actually see what we are doing over here is, we are just calculating the probability of yes and no at each step. And we are figuring out that what percentage is higher, whether it is yes, which is in higher percentage, or it is no in the higher percentage. And at that last level, what happens is, when you do not have any further differentiation that can be done, so you can see over here, this is the final predictions that it gives you, that on the basis of agreement, how much people will leave. So there is a 13% chance that if a person who is having a 2-year agreement, that he will leave your services, right? Because this is, now I'm just explaining this last node so you can make sense of it. Over here, like, if suppose there is a person who has already taken a 2-year of subscription, so in the middle of that subscription, there is very low chance that he will change his services, correct? Because he has already paid for that 2 years of time. Now, same way, if you come over here, that when you say total amount over here, when the amount is more than 1182. So over here, we have seen when the charge is going high, the people are leaving your services. So there is a 71% chance that the person will leave your services. And they were, in order to create this node, what this decision tree has done is, it has used 5% of the data. So if you will see it, this over here, this decision tree that we are creating, okay, this decision tree that we are creating over here, at each step, it is showing you that what percentage, how many percentage of records did you have for that particular analysis that it has done. If you will add up all these percentages, it will come as 100% over here, right? So this is basically how these percentages are being shown. What percentage of data has been used in order to come to that conclusion, and what are the chances whether a person will leave or he will not leave based upon that data that was there at that particular node. Okay, up till here, right, this much part that we have discussed, is it clear to all? So just do not worry about all that other stuff that you see, because this we have not discussed as of now, right? This is something that I will be explaining you. So Sakshi, pruning was done over here only, where we have defined this while creating the model. Okay, while creating a model, I have defined that control equal to list max depth. What is the error that you are getting? So Raghu, what error are you getting for that particular fancy R plot? It should support, actually, have you installed that package of Rattle? First of all, you have to make sure that this package is installed. No, you will not get this function over here, right? First of all, you will have to install a package, Rattle package. So sorry, if I missed that step. So you will have to install that packages, Rattle. Okay. Once you install this, then only you will be able to get it. No, so Sakshi, this is not about the number. 6 is not the number of observations. This is the depth, the number of branches, right? If you see over here, 1, 2, 3, 4, 5, right? It will go up to only the 5 levels, maximum of 6 levels. It will not go beyond that, because if you see, there were lots and lots of other variables also that we had in the data. If I wouldn't have defined the pruning, right? Let me just remove this step from here. Okay, because right now it is not exceeding because that complexity parameter is something that is getting increased over there, right? Because of that complexity parameter, because as it is going from one step to another, the complexity parameter is actually increasing. So that is why it is any which way is not going over there. Let me define that thing the other way around. So it makes more sense. Because the more data is such that it is not going beyond that. You see now, my layers have now reduced, right? Maximum depth I defined of 2. So this total data, and you just have 2 layers, two level of depths, 1 and 2, right? So this is pruning. So because my complexity parameter is increasing, so it was not having those many layers. If I add 3 and I add this, we will get one more layer inside this. Okay, so if I increases 1, 2, 3, and 4, you get the layers according to that. So Sachi, but how does my data decide which nodes to cut down? See, it is in the order of significance, right? So as the significance will drop down, it will cut down those branches or those variables from that tree. It is purely on the basis of significance. That's it. Okay. Sure, Mahesh. So I will advise you to watch the video of yesterday's session and the session that we had on the last Sunday. Okay, 2 of the videos I will request you to watch before the next session. Okay, so because in the next session, what we will be doing is we will be covering this decision trees ahead, and in the next session, definitely it will be completed. And then we will be starting with the fresh modeling technique that will be of LDA, that is linear discriminant analysis. Okay. Yeah, so I think this is where we'll take a pause, right? So we will continue from here the next week. Okay. So with that, right? So before we leave, any questions, any queries that you would like to ask, anything that you want me to put on the drive before we meet in the next class? And also, Mahesh, there is something over here, there is a drive that I have created over where you will find all the material and some other stuff related to this session. So I'm sharing that link also with you over here. Yes, Sakshi, the PPT is already there on that drive. Okay, so I'm sharing this link. So Baldev, you will find the Titanic, the code in the PPT also, and I will upload that code of Titanic over here again as well for the Titanic data set. Let me do it just in next 5 minutes. I'll just do that. Okay, everyone. So see you all next week and wish you all a very happy new year in advance. Okay. Thank you all. Yep. Happy New Year 2021. So hope it's a new year with some changes. in our day-to-day life that we are having.